All right, welcome back. So just to recap for a moment, what we did in the last video is we figured out how to devote resources, right, labor and land, to the production of two goods, avocados and strawberries. And essentially what we concluded is that if we like avocados and we like strawberries, we want to be allocating resources somewhere along our producer's contract curve, right? This black line that we drew here, where MRTSs touch each other at just one point. The reason we say that is if we were somewhere off of our producer contract curve, somewhere like C, there would be an alternative that's clearly better. In this case, A is clearly better because we're on the same isoquant for avocados, right? We produce as many avocados at A as at C, but we're on a better isoquant for strawberries, right? We're going to get more strawberries at A than at C, so we're getting something without giving anything up. However, we don't have any way yet to say whether we'd rather be somewhere like A, where we get lots and lots of strawberries and not very many avocados, or somewhere like B, where we get lots and lots of avocados and not very much strawberries. Because we haven't thought at all about what our different outputs are worth. So what we're going to be doing in this video is thinking through the problem of what we ought to produce, given we've got some production process, which we've thought about here, and given that we have consumers who value goods in different ways, which we thought about in the last lecture video. And the basic process we're going to do this is going to be the same as what we've done for our last two pieces of this puzzle, where we're going to start out by thinking, if we're some benevolent social planner, right, we're trying to think from a mile-high perspective, what ought to happen, what's the right output to choose, and then we're going to think, is a competitive economy, are market forces and competitive processes going to lead us to choose that right output? Cool. So the first thing I need to do, if I want to think about what the right output to choose is I need to know what all my options are. This is the same process we've done every time we've solved an optimization problem in this class. We've started by saying, well, what are all of your options, right? If you're a consumer, what's your budget constraint? What's affordable? Once we know what's affordable, we can pick whatever's best for you out of that set of choices. If you're a producer, we say, what's your isoquant, right? What are all the options of labor and capital that will produce enough output? Once we know all of your options, we'll pick whichever one you like best, right? Whichever one's cheapest. So we're going to do exactly the same thing here. We're going to say first, what are all your options? What are all the ways that you could produce? What are all the combinations of avocados and strawberries you could produce? And then we'll say, which do we like best, right? What are the combinations of avocados and strawberries that we should produce? Cool. So the way I'm going to do that, figure out how many avocados and strawberries I could produce, is I'm basically going to take the information on this graph here and just transmogrify it onto a new graph where instead of labor and land, I'm going to have strawberries and avocados. And essentially what I'm going to get here is something that looks kind of like a budget constraint for society, right? A combination of all the things that's possible for me to produce. So to start with, if I'm going to try to take points from this graph and move them onto that graph, why don't I pick two really easy points? So I'll start over here, what I'll call point 1, which is where I'm not growing any avocados at all. I'm devoting all of my resources to growing strawberries. So I'll end up somewhere with no avocados and some number of strawberries. So then the question is, how many strawberries will I get if I use all of my labor and all of my land to produce strawberries? The answer will be, I'll just look at my production function, and I'll plug 250 into LS, right, because I'm using all my workers to grow strawberries. I'll plug 1,000 into KS. I'm using all my capital to grow strawberries. So I'll say S here is going to equal LS to the 1/3 times KS to the 1/3, right? So that's going to equal 250 to the 1/3 times 1,000, I'm sorry, to the 2/3, 1,000 to the 2/3. And this is going to be a somewhat horrible number. It'll be 250 times 4 to the 2/3, which comes out to something like 575. So if I use all of my resources to grow strawberries, I can get something like 575 pallets or bushels or whatever our unit is of strawberries. Great. And this point 1 here, right, corresponds to this point 1 here. Another easy point, let's go to point 2 here, right, where we're using all of our resources to grow avocados, none of our resources to grow strawberries. I'll call this point 2. And I'll do the same thing to figure out how many avocados I can get. Also, that A is going to equal LA to the 1/2 times KA to the 1/2, right? Our production function for avocados. So this is going to equal 250 to the 1/2 times 1,000 to the 1/2. And that actually turns into a pretty nice number, because it's 250 to the 1/2 times 4 to the 1/2, which is of course, or 250 times 4 to the 1/2, which is of course just going to equal 500. Cool. So how I'm doing this, right, is I'm taking the inputs I'm using to grow each good, plugging them into our production functions to figure out how much I get. So now I want to know, right, what's the shape of my curve going to be here, right? Is this going to be a straight line? Is it going to sag in like this? Is it going to bulge out like that? So in order to think about this, of course, we could calculate this line actually by plugging in all the possible values of FA and KA into our production possibilities. I'm sorry, our producer contract curve, but that'd be ugly and horrible, and I'm not going to do it. So what I'm going to do next is I'm just going to pick one more spot, 0.3. That's going to be where labor equals 100. Right, so LA is going to equal 100. And then we know what KA has to be, right, when LA is 100, because we know we're going to be on our production contract curve. So KA is going to be 500 over 250 minus 1/2 LA, all times LA. So KA is going to be 500 over 200 times 100, right? And this is going to be 500 over 2, which is going to be 250. Great. And so how many avocados can I grow with 100 workers and 250 acres of land? Will just be F of LAKA equals 100 to the 1/2 times 250 to the 1/2, which is going to be about 158 avocados. And how many strawberries will I get? Well, I'll use all of the workers that I don't use to produce avocados to produce strawberries. So this will be 150 to the 1/3. And all the capital that I don't use to produce avocados, so times 750 to the 2/3. And that'll be about 520. So we can put a third point here, where we essentially lose about 55 strawberries, right? Go down to 520 strawberries. And we gain 150 avocados, right? So we add 150 avocados, we'll have some point like this. And so as we can see, we combine these points, we're going to end up with a curve that looks like this, that bulges outward. Right, and we can see this because to get our first 150-ish avocados, we only had to give up 55 strawberries. Right, to get our next, our next 350 avocados, we had to give up 520 strawberries. Right, so the number of avocados that we're getting per strawberry we give up is lower when we've got lots and lots of strawberries and few avocados than we've got lots of avocados and few strawberries. Now the exact numbers here aren't super important, but what is really important is to note two things. The first thing is that the way that we're drawing this curve, right, the way that we're thinking about all the combinations of strawberries and avocados we can afford, is by taking each point on our producer contract curve and figuring out how many avocados and how many strawberries we get at that point. If we picked any point off of our producer contract curve, like point C, we would end up with some option below our production possibilities frontier here, right? Because we'd be producing fewer avocados and strawberries than we're ultimately able to, right? We'd be underperforming. And it doesn't matter if we're on this side or that side, right? If we had some point D would also end up somewhere like here. Cool. The other thing that's really important about this is the fact that it's bending, right? The fact that it bulges out the way that I drew. Another way of thinking about this, right, is that the slope of this thing is less steep when we're growing lots of strawberries and very few avocados than when we're growing lots of avocados and very few strawberries. So I want to just take a second to think about why this makes sense, based on what we've done so far. The basic idea here is, this curve is bending because when we're growing lots and lots of strawberries and very few avocados, right, when we're down somewhere like this, we're going to be producing our avocados in a relatively labor-intensive way, right? We said that we'll use about 1 worker for every 2 acres of land in avocados, and 1 worker for every 4 acres of land in strawberries when we're down here. Another way to think about this is, when we're increasing production of avocados, we're predominantly using resources that are better at growing avocados than they are at growing strawberries. And so as a result, we don't have to give up that many strawberries to get a lot of avocados. Once we're down here, right, where we're growing lots and lots of avocados and very few strawberries, the exact opposite is the case, right? We're producing our avocados, then we're using all of our resources to produce avocados, including land that's more productive when we're using it to grow strawberries, right? Because strawberries are relatively land intensive, relatively less labor intensive. So down here it's the opposite, right? We're producing our strawberries with lots and lots and lots of land and very little labor, so we could get lots of strawberries without giving up that many avocados, because we're using resources that are relatively less effective at growing avocados than they are at growing strawberries. If we thought about this in a slightly bigger picture way, right, abstracting from just 2 goods, strawberries and avocados, it's maybe a little bit clearer, right? If we think about the real economy that we all live in, we see this sort of situation play out when, for example, a country goes to war. You have all sorts of resources that are really good at producing peacetime things, right? You have dentists who are really good at cleaning teeth and not particularly good at fighting wars. All of a sudden shift from tooth cleaning to war fighting. Whereas when you're at peace, right, you have a very small military, the only people in the military are people who are very, very good at being in the military and aren't that great at cleaning teeth. Likewise, right, we're going to have all sorts of capital and resources that aren't that great at making military equipment shift when we go into a wartime economy away from, making marshmallows or making confetti or making lawn ornaments towards making bombs and missiles and uniforms and guns. So I'm going to call this thing that I'm drawing here, right? It's coming out of our producer's Edgeworth box. I'm going to call this our production possibilities frontier. Right? Because it's telling us all of the combinations, all of the amounts of production that are possible, right? And the frontier, because we want to be on the bleeding edge of production, right? We want to be as productive as possible. And I'm going to call the slope of this thing at any given point the marginal rate of transformation. So why am I calling this the marginal rate of transformation? Because it's effectively telling us, right, if we think about what the slope of this curve is telling us, it's telling us how many strawberries we have to give up to get an avocado, right? The change, rise over run, right? The change in strawberries over the per change in avocado. And so if we wanted to kind of have a magical realism take on this, right, we want it to be really fantastical in our thinking, we could say, this is the rate at which you can transform a strawberry into an avocado, right? When we're up here, maybe we can transform 1 strawberry into 2 avocados. Down here, we would have to transform 2 strawberries into 1 avocado, right? It's essentially telling us how much of strawberries, how much of the vertical good we have to give up to get the horizontal good. I want to take a second to think about what the marginal rate of transformation is going to be. So to think about this, let's note that while the magical realism version of what's happening as we move along our production possibilities frontier is that we're performing some alchemy to transform strawberries into avocados, what's actually happening as we move along our production possibilities frontier is that we're shifting resources from the production of strawberries to the production of avocados, right? So when we think about our marginal rate of transformation, it should have something to do with, essentially, how many strawberries we lose by shifting resources towards avocado production versus how many avocados we gain. In other words, right, our marginal rate of transformation some number of avocados and strawberries, right, which again is the slope of our production possibilities frontier, is going to equal the change in strawberries that comes about from changing avocados, right? The number of strawberries we have to give up to get an avocado. And this in turn is going to be the change in the number of strawberries we get by changing our inputs, right? DSDL, let's say times the change in labor, over the ADL times the change in labor, right? In other words, what we're saying is, if we transfer workers from the strawberry industry to the avocado industry, the number of strawberries we lose is how much those workers were producing times the number of workers we transfer. The number of avocados we gain is the amount of avocados those new workers produce times the number of workers that we transfer, right? This cancels. So we're just going to say MRT, A and S, is going to be the ratio, the marginal product of labor, in the strawberry industry to the marginal product of labor in the avocado industry, right? Now you might be wondering, well, why did we say labor here and not capital? And the answer is it doesn't actually matter. The reason it doesn't matter is we could also define this also equal to, right, BS dk over BA dk, right? But we know that when we're producing efficiently, right, when we're on our production possibilities frontier, we know that our MRTSs have to be equal, right? So we know that DSDL over DSDK equals DADL over DADK, right? So I could multiply the top of this by DSDL over DSDK, the bottom by DADL over DADK, and come back to this. Not super important, but if you're wondering what I'm doing here, that's something I just wanted to point out. Okay. So what we're ultimately saying, right, is that our marginal rate of transformation is going to depend on the marginal product of labor in one industry relative to in the other industry, right? At the number of workers and capital at which we're producing. The reason that this thing is going to be bendy in the way that it's bendy is because all of our inputs are going to be more productive on the margin in growing avocados when we have very few avocados than when we have a lot of avocados relative to their productivity in strawberries. Cool. And I have some math in the lecture notes showing that that's true, showing that our marginal rate of transformation is changing as we increase avocado production. But I think it's too much of a distraction and I'm not going to have you do it, so I'll skip it for the lecture videos. Wonderful. So what we've done so far, right, to try to figure out how many avocados and strawberries we ought to make, is just try to figure out how many avocados and strawberries we could make. And all we did is we said there's a bunch of efficient ways to organize our inputs, right? Some of which produce more strawberries, some of which produce more avocados. Let's put them all down on a graph. And let's figure out the slope, right? The trade-off we have to make to get an avocado by giving up a strawberry at different numbers of avocados and strawberries. So far so good, right? We're on the right track. But so far we haven't figured out the answer to the question we started with, which is how many avocados and how many strawberries should we make, right? What's the right number, what's the right choice out of all of these options on our production possibilities frontier? So let's think about how to answer that question, right? Let's think about which of these options here is the best option. Now, the tricky thing about this is that there's lots and lots of people, right? We're talking about a whole economy. We're not just talking about a single person with a budget constraint. So for now, let's forget all that and imagine there's just one person consuming everything, the only person we care about. Let's call them Emperor Zod, right? So if we just have some Emperor Zod that likes avocados and likes strawberries, then figuring out what Emperor Zod's favorite choice would be very straightforward, right? We would just draw indifference curves for Emperor Zod. And what would the best choice be? Well, it would be the choice where Emperor Zod is on his highest indifference curve, given that he is on the production possibilities frontier, right? So this right there would be the best. Cool. If we wanted to characterize this point mathematically, it would again be reasonably straightforward to do this, right? We would essentially say that we need two things. The first is going to be that we're on, right? So we're characterizing Emperor Zod's favorite. Right? The first thing that we need is going to be that we're on our production possibilities frontier, right? On our PPF. And the second thing that we need is going to be that the slope of Emperor Zod's indifference curve has to equal the slope of Emperor Zod's production, or I'm sorry, the slope of the economy's production possibilities frontier, right? That's why something like this isn't the best choice, because there's overlap, right? We could do better by moving to a higher indifference curve. So the second thing is that the MRS for Zod of avocados and strawberries has to equal the MRT for the economy of avocados and strawberries. Cool. So that's nice, right? This tells us that we know how to pick an option on our production possibilities frontier that's best for someone, but we still don't know how to pick an option that's best for everyone. So to think about that, I want to take you back to last lecture and think about what we concluded about what an efficient allocation of resources looks like in an endowment economy. In other words, once we've decided to make avocados and strawberries, what will it look like if we're divvying up the avocados and strawberries in an efficient way, right? Between, let's say, Zod and Mod. Right? Well, what we said, right, is that Zod's going to have indifference curves like this. Mod's going to have indifference curves like this. Right? And the best choices, or all of the efficient choices, are going to be the combination of avocados and strawberries. Where we can't make one of them better off without making the other one worse off, right? In other words, if we've got allocative efficiency, right, we're distributing the goods properly, we need to be somewhere on our contract curve. In order to be on our contract curve, we need the Zod's MRS has to equal Mod's MRS. So what's that going to look like on this graph? Well, it means that at the point where output actually is produced, right, with the number of avocados and strawberries that end up getting distributed to the consumer market, right, and divvied up between Zod and Mod, we're going to have Zod's indifference curve have the exact same slope as Mod's indifference curve, right? Because otherwise, they would be able to trade and become better off and become mutually better off, right? So if output is being efficiently allocated once it's produced, we know that where our indifference curves touch our production possibilities frontier, the MRSs of every single individual have to be the same. Right? Even if we had, perish the thought, 3 people in our economy, all 3 of them would have to have the same MRS at that exact point. Otherwise, they would benefit from trade. So we're going to have output efficient production of avocados and strawberries when everyone's shared MRS, right? Everyone's shared relative valuation of avocados and strawberries is equal to the MRT, right? The number of strawberries we'd have to give up as producers in order to generate more avocados. So one last thing I want to show you is what this would look like if we had exchange efficiency, but we weren't producing the right level of output. Let's say, for example, that we were producing here, right, where Zod at least would really prefer to give up some avocados and get some strawberries. If Zod, Mod, and all the other, and Claude were all negotiating effectively in the exchange market, they would all feel the exact same way about the relative value of strawberries and avocados. Right? So maybe Claude would have difference curves like this, right? Mod might have indifference curves like this. And Zod would have his indifference curve we already drew. So what this would mean is, they all have different preferences, right? All their indifference curves have different shapes and different slopes, all this stuff, at every point but the point where we're producing. But because of the fact that they're all negotiating together and divvying up output in an efficient way, if we're not producing the right amount of output, every single one of them would be happier if we made more strawberries and fewer avocados, right? All of the people cry out together in one voice, bring us more strawberries, enough with the avocados. I want to throw just one last thing at you, and then I promise I'll let you leave. Thank you so much for sticking through a really challenging and pretty long video. So, the last thing I want to throw at you is thinking about if what we need to produce the right amount of output, right, to be output efficient, is to have our marginal rate of transformation equal the marginal rate of substitution for all of our consumers. Are we going to get this in a competitive equilibrium, right? Will market forces push producers to produce the right amount of output? So to think about this, let's think about what each producer is going to do in a competitive market, right? Where they're choosing how much to produce based on their costs and based on the prices. So if we thought about a specific strawberry producer, they're going to produce where price equals their marginal cost, right? Well, what's their marginal cost? Well, their cost function is just going to be W times L of Q plus R times K of Q. Right, so their marginal cost is going to be the cost of whatever inputs they need to produce a little bit more output. Right, and it's going to turn out that it doesn't matter if they produce a little more output with labor or with capital. So we can think of the marginal cost as just a change in labor if we want to increase output a little bit. So what this means, right, is that our marginal cost in the strawberry business is going to be W times the L dQ, right? And this is going to be dL dQ is just 1 over dQ dL, which is the marginal product of labor. So this is just going to be W over the marginal product of labor in the strawberry business when producing Q strawberries. Cool. How about avocados? They're also going to produce where price equals marginal cost, right? Their cost function is also going to be WL plus RK. So by the same logic, right, the marginal cost of an avocado producer is going to be W over the marginal product of labor in the avocado business, right? So what does this tell us? And then as a result, right, we're going to say that the price here is going to equal W over MPL S, right? Our price here is going to equal W over MPL N. So what does this tell us about our price ratio? Right, the price of avocados over the price of strawberries. Well, it tells us that PA over PS has to equal W over MPLA over W over MPLS, right? If we multiply up, we'll therefore say that PA over PS is going to equal the marginal product of labor in the strawberry industry divided by the marginal product of labor in the avocado industry, right? We're saying is the relative price of avocados to strawberries is just going to be inverse of the relative productivity of inputs when producing avocados to producing strawberries. And that is exactly equal to our marginal rate of transformation, right? Which was going to be the ratio of the marginal products, right? The number of strawberries we give up to produce an avocado is exactly MPLS over MPLA, So that tells us that in a competitive equilibrium, our price ratio, PA over PS, is going to equal MPLS over MPLA equals the marginal rate of transformation. Well, what about our marginal rates of substitution? We know that in a competitive market, when people are choosing interior solutions, they're going to purchase goods until their marginal rates of substitution are equal to PA over PS, right? So we know that the MRS of every individual also equals PA over PS, right? So this tells us that in a competitive market, MPLS over MPLA equals consumers' MRSs, right? In other words, we have that the marginal rate of transformation equals each consumer's MRS. Therefore, competitive markets are going to be output efficient. We're going to produce the right amount of stuff. Awesome. So I'm going to leave it there for today. Next lecture, we're going to talk in a more big picture, less mathematical way about what to make of all of this and how to tie this all together into a conclusion about the nature of capitalism.